The next step is to take a relatively pure stream of these materials and clean it up, because after all, this stuff was garbage. The first thing we will do is grind it, and you see that happen in the following slide. Now, not everything will be the same here. You might have some materials that float and some materials that sink. If we think about a soda bottle, for example, the clear part of the soda bottle is PET. It will sink. The white part, the caps of the soda bottle, are polypropylene, and they will float. So what we can do in this process is grind them all together if there are some caps there. And we're going to separate by taking material off the top and the bottom of the float sink tank. But first we're going to wash it. The material goes into the wash tank. It's stirred with various kinds of soaps that take the dirt off. And then it's rinsed and sent into the float sink tank that you see. Now, if I were going to take material off the bottom, I would have an auger that goes down into the bottom of this tank, and what it would do is just sort of auger the material up. Then the other material I'll harvest from the floaters by cutting a little hole in the side of the container, and then I will gently move the water across, and off will come the floaters along with it. And in both cases I'll separate the water and then dry the material. Then once it's done, I'll put it through what's called a cyclone. And a cyclone is kind of like a centrifuge using air. But what it does is take materials that are aerodynamically very light, like dust or labels, and send them out the top. And the materials that are aerodynamically kind of heavy, like pieces of plastic, fall out the bottom. So it's another mechanical way of separating out dust, dirt, and labels that I don't want, and leaving me with a clean stream of plastic at the end. Finally, if I have the odd flake or two of material in my clean flake that consists of something that I don't want, I can go through another binary sort, except this time, instead of ejecting containers, I can eject flake. And the way I would do this is have a visual device detect a flake that's not what I want, and then an air stream ejects some of the flake from the stream and leaves me with pure material. So the step that we use now is called melt filtering. I can melt it, and I'm going to push it through a metal screen to catch the last bits of unmeltable stuff. And then off it goes through a strand die where it's chopped and turned into pellets. Now, a lot of times people will ask me, well, okay, how many times could I recycle this thing? If I keep bringing it back and bringing it back, then ultimately it's going to have to be recycled over and over again. So the answer to the how many times question is, not surprisingly, it depends. Now, what does it depend upon? It depends on the type of material, first of all, because some materials are more susceptible to having their little chains break with heat. But it also depends on how you treat them afterwards, because some materials, like PET, you can put the little chains back together again in a process called solid stating that brings the molecular weight back up. But now for something like milk bottles, once you break the chains, you're done. And the materials could be recycled 5, 6, 7 times fairly easily if you treat it rather gently. If, on the other hand, you don't treat it gently, you can take some of the life away. But in many cases, you will find that the recycled material is blended with virgin material, so you never will totally see the effect of having reprocessed the material. So how many of you have ever been checked out on this particular piece of equipment? Yes, it's a Play-Doh fun factory, and interestingly enough, it is very similar to the kind of device that is used to process plastics on an industrial basis. So today, we're going to be making pipe using our Play-Doh fun factory, and you notice we're making pink pipe. Anyway, we make the pipe. When it gets to the right length, we cut it off, and then we just sort of ship it to the Home Depot from there. Now, if you really want to confuse a kid of about the age of 7, ask him how the hole gets in the pipe. And interestingly enough, it looks just like the way you do the Play-Doh fun factory pipe. You notice that in the back of the die, you have a split that forces the Play-Doh into 2 streams. And then from the front, you see you have a disc that forces it to the side. So in fact, what you are making is not a pipe, but 2 half pipes. And then you take the 2 little half pipes and you sort of put them together, and that's how you wind up with a pipe. Curiously enough, that's just exactly the way you make a pipe on an industrial basis. What we're looking at here is a pipe die, and on the left, you see the flow in comes from the left, and it passes over a torpedo-shaped thing called a mandrel. The mandrel sits in the flow and is suspended there by what are called the adjustment pins. Those are there to make sure that the mandrel is put right in the middle, because you don't want a pipe that has a wall that's thinner on one side than it is on the other. But now notice, when the melted plastic is going over those pins, the melt is cut. But once again, our old friend entanglement comes forward, and because the material is hot, once it's past the pins, those individual molecules will entangle again, particularly as they're forced down into shape through the end of the die, as you see it on the left. Then, within about 18 inches, the hot, flexible pipe goes into a water bath where it freezes and becomes the rigid pipe that you buy in the hardware store. The second process for our Play-Doh Fun Factory is making bottles. Now, first of all, let's ask ourselves a question. Topologically speaking, what's the difference between a pipe and a bottle? I don't see many hands. On the other hand, if any of you came up with something other than the bottle has a bottom in it rather than a no bottom like the pipe, then I'm never sending you off for bottles for me. We can go ahead and make our bottle with the Play-Doh Fun Factory, where I extrude a tube, and then all of a sudden Mr. Hands comes up here just like this and pinches off the bottom, and then we cut the top. And I would argue that that is in fact an anatomically correct, if early in its development, bottle. Interestingly enough, when you make real bottles, it's not that different than the process that we've shown you here. To make things like milk bottles or other laundry detergent bottles, the first thing that you do is you extrude a tube. That tube is called a parison. Then you have a mold that comes and clamps the parison like this. It comes together at the bottom and pinches the bottle off, and in fact makes a cut. At the top it's open, and down through the top comes what's called a blowpen that then blows air into the bottle. It blows to the sides of the mold, which are cooled. It freezes at the side of the mold, then the mold opens, and out drops this fully formed bottle. This is the bottom of a milk bottle, and you can do this experiment at home, although I would urge that you do it with an empty milk bottle rather than a full one. Turn the bottle over and have a look at the bottom, and you will see where the bottle has been pinched off, and you'll see two little smiley things on either side of the pinch off, and that will tell you how big the parison was when it was extruded out of this extruder. Now, we're going to talk about striped toothpaste. I remember when striped toothpaste first came out. It was about 1960. I couldn't figure out how they got the stripes to come out of the tube so straight. In fact, I think that's the reason I wound up going into science, was to figure out how striped toothpaste worked. You see, you have two reservoirs of toothpaste. You have a red reservoir and a white reservoir. When you squeeze the tube, you squeeze the white down through this dip tube that you see in the middle, and you squeeze the red through the little holes in the bottom. That makes bits of toothpaste come out on top of the white cylinder of toothpaste that you squeeze through the dip tube. And that's how you get stripes. But you could make bigger stripes, I suppose, if you wanted to, by making the holes bigger. And in fact, if you made the holes bigger and bigger to the point where they almost touched, you could come very close to making an entire red coating on the white piece of toothpaste. Now, since we've already talked about how you put holes in things, it's only one more step to get to the point where instead of making striped toothpaste, I have now made a cylinder of white material covered by a cylinder of red material. And that is why I dragged you through this entire operation, is because what I wanted to talk about was not extrusion, but co-extrusion. And the reason is because it's important for recycling. Most of the laundry bottles that you find in the store will have a little sign on the back that says 25% recycled content. And the way that recycled content gets in is by a co-extrusion process, like what you see on this slide. You will see that the recycled material goes in the middle, in between two layers of virgin material, to make these laundry bottles.